It's insane to think that Vue's been around for 10 years now, that all the way back in 2014, Evan was working at Google, realized that the state of JavaScript frameworks wasn't great. He wanted to do something different, and he certainly did with the original release of Vue, following soon after with Vue 2, and then the groundbreaking set of changes that were in Vue 3. It's been a wild ride for people in the Vue ecosystem, and it's had massive impacts well beyond the Vue world. I know that a lot of the cool stuff that's been happening in the React world in particular is heavily inspired by Vue, Nuxt, and the stuff going on over there. One of those things that's been exciting for a while for me now is Vue Vapor. If you're not already familiar, you might be familiar with React Forget / the React compiler. If you're not familiar with that either, maybe you're familiar with Solid. And if somehow you don't know any of those, it's going to be a great video for you to watch because the future is going to be using these types of technologies to make our code more efficient. Right now, we're expected to do a little bit too much work if we want our code to be reliable and reactive without running a bunch of stuff on the user's devices. And with the work that Evan's put into Vue Vapor, things are getting really exciting. So what the hell's going on here? Well, first, let's talk a little bit about signals. Here is a pretty traditional component tree. You could have something like this in React. You can have something similar to this in Vue as well. I think this is a good point to start with because when you write this code, which would look something like app, top nav, counter, we can all roughly understand what's going on here. You have an app that has two children. One is top nav and one is counter. These things are not related to each other, but they share a parent. Right now, this is just when you run this code, what comes out. What happens when it needs to update though, like this counter component? Well, if the counter had its own state bound to it, like let's say this has a count number is a value that this guy has. Now, whenever this changes, this component has to be changed too. So it's pretty easy to imagine that this counter button has these two children elements. One is the button element, which is the button you click to increase count, and the other is the count itself. Since the count's only being used in the span, it would be ideal if the only thing that had to update was the span. But since the count lives in the counter, it's also going to have to re-render the button every time you increase the count. Because the way React works is when state changes in something, everything below that thing has to change too. So if we had this count defined as count set count equals use state 0, pretty innocuous, simple, innocent looking code. If we had this here, then everything below counter has to rerun whenever count changes. If we had moved it up here or put it in a context or something, then top nav would have to re-render too. If we pass these values of count and set count down to the counter, top nav will also have to re-render whenever it changes, which is kind of insane when you think about it, because the only place count's actually being used is way further down the tree. Ideally, only this should have to change and nothing else should. React's solution to this is the virtual DOM, where all of these elements exist in JavaScript, where they can identify changes much more easily. And then once they've identified what has actually changed and what hasn't actually changed, it can then apply those changes to the DOM. So even though I said here, when count changes, it has to re-render all these things, re-render doesn't mean it's updating the actual element on the page. It means that React's reconciler layer and React's virtual DOM layer are checking each of the nodes to see if the result is different. And if the result is different, it will update the content of the page. I'm not deeply familiar with Vue's model for this, but from my understanding, it is very, very similar to what I've described here. This has its issues though. Let's say button is slow to render. Let's say top nav is even slower to render. So doing these checks ends up being expensive. Ideally, we'd be able to identify when specific things do care about this update and other things don't. The way we do this in React is with memos right now. So I could wrap this button with a memo before exporting it. And now React knows unless one of the props this took changed, it just doesn't matter. Just ignore it. And if you were to properly memoize things, like we also memoize the top nav here, then we would be able to skip a lot of these unnecessary updates. Not only is this annoying to do as a developer, going and adding all the right memos in the right places, it's also doing additional checks and storing additional data in order to make sure it doesn't have to go down this path. It can absolutely save a ton of compute if it doesn't have to go down all of the children of top nav, but the comparison check to see if it needs to do that in the first place is a separate compute cost. You now have to worry about that. So this is great. The way that Solid solved this, if I was to just copy all of this over, if you don't know Solid, it's an alternative JavaScript framework for JSX developers to have really, really performant web apps. It's considered one of the, if not the fastest web framework. So it's a really good reference for how to do these things in performant ways. And the DX is also pretty good. So let's take this React example and make it a little more solid. First thing we have to do is change the use state to create signal, because Solid doesn't use traditional reactive state, which they would argue isn't even reactive, where things re-render from the top down. Instead of thinking of your app as these components, you can think of each individual piece of state as having its own component tree. It's not components, it's a tree of where the updates have to go. But now we need a way to create these relationships. The way we do that is instead of calling count just by referencing it, we actually have to call it as a function because it's not a value, it's a signal, which is bound by a function call. So now when I call count here, Solid says, hey, browser, this element is attached to this value. So now whenever you call set count, Solid will go through and update count in all of the relevant places that are calling this binding. That is what a signal is. Rather than the components being the thing that defines the lifecycle and you get the new state when you're running those lifecycle changes, instead, the values have lifecycles of their own and those values update things in the DOM instead. So instead of your components changing what's in the DOM, you can almost think of this like your components are a template and the count and the other stateful values, those are creating their own tree of updates themselves, which is a really weird way of thinking about this until it clicks. Then it's like, oh, instead of drawing app, top nav counter, maybe I would draw all of that as one thing, but count goes to these different places. And you have these flows of state throughout your app. In some ways, this is significantly easier to understand and reason about. In other ways, it's more difficult because once these states start to interweave, keeping track of which ones go where and which flows go up, down, left, or right can get a little more difficult. But overall, so many things get much, much simpler when you move towards a signal model, which is why we see almost every other framework going in this direction, including even Angular, which is crazy to think. One last thing we need to talk about before we can go in on the Vapor stuff. The way that Vue's state works now is important to understand. This is a great section of the Vue docs where they talk a bit about how their state management is both similar and different to signals, which I think is really important. As they call out, quite a few other frameworks have introduced reactive primitives similar to refs from Vue's composition API under the term signals. Fundamentally, signals are the same kind of reactivity primitives as Vue refs. It's a value container that provides dependency tracking on access and side effect triggering on mutation. This reactivity primitive-based paradigm isn't a particularly new concept in the front-end world. It dates back to implementations like Knockout and Meteor from more than a decade ago. To be fair, Vue is now a decade old too, but yeah. Vue Options API and the React State Management Library MobX are also based on the same principles, but they hide the primitive behind object properties. Although not a necessary trait for something to qualify as signals, today the concept is often discussed alongside the rendering model where updates are performed through fine-grained subscriptions. Due to the use of the virtual DOM, Vue currently relies on compilers to achieve similar optimizations. This here is a very important callout because other frameworks like Solid, they don't use compiler steps. The actual way you write it handles a lot of this for you. Whereas in Vue, in order for them to keep the syntax from changing too much and to provide the DX they were looking to provide, they rely on the compiler to do a lot of these optimizations. Other frameworks are experimenting with these heavier compilers. Obviously, Angular is the OG weird compiler framework, but even Svelte does some crazy stuff with their compiler to try and optimize things based on the syntax. Solid and React are the two that don't really do much of this. They kind of just use Babel and existing transformers to generate the JS that comes out, and they let the framework handle it. It's interesting to see how much Vue has historically leaned into using compilers to achieve those optimizations and is now going even further with Vapor Mode. As Evan specifies here, they're exploring a new Solid-inspired compilation strategy, Vapor Mode, that doesn't rely on the virtual DOM and takes more advantage of Vue's built-in reactivity systems. Very interesting stuff. In this doc, they even call out Solid as an example, showcasing what a create signal does, and wow, that's kind of similar to the thing that I just showed. Really convenient. Signals are exposed as a read-only getter and a separate setter. So you can't do an equals binding. You have to call the setter and the getter, which is similar to React minus the getter. But that's an important change because, as it says here, notice how the count signal can be passed down without the setter. This ensures the state can never be mutated unless the setter is also explicitly exposed. Whether the safety guarantee justifies the more verbose syntax could be a subject to the requirement of the project as well as personal taste. But in case you prefer this API, you can easily replicate it in Vue. Interesting, because again, in Vue, you have a ref that you can update by setting it to something with equals, or you can get it by just accessing it. But if you want that level of granularity, you have to write it yourself, and you don't get the compiler benefits either here, which is an interesting difference. I do like that they're calling out this comparison and showcasing how admittedly not super ideal this flow is, but it works, and it's cool that you can replicate these styles. That said, now you're writing this to have the same syntax as Solid and then compiling it to have the same behavior as Solid. It almost feels like you're faking it on both sides, which isn't my favorite thing in the world, but it's overall pretty cool that you can replicate these things. That to me says this primitive is pretty good. Whereas in Solid, if you wanted to set count with the equal sign, you can't do that. The only time you use equals for this in Solid is when you actually bind the initial signal. Whereas in Vue, you just set r.value equals, similar to what you do in something like, I don't know, Svelte. Faking signals with fake signals. Yeah, fair. If you guys didn't know, I mentioned it a bit before, Angular is also going through a signals reinvention of the framework. They have a similar syntax to Solid where you call the count as a function, but instead of having a different setter that's a different function, you call count.set. Don't love this because it doesn't do a great job distinguishing these different states, but I see why. It gives you this one thing you can pass around. It's pretty nice. The Angular Signal API is an interesting concept. And again, you can replicate this using Vue. Compared to Vue refs, Solid and Angular's getter-based API style provides some interesting trade-offs when used in Vue components. This is slightly less verbose than .value, but updating the value is more verbose. There is no ref unwrapping. Accessing values always requires calling the function. This makes value access consistent everywhere. This also means you can pass raw signals down as component props. If you didn't know this, within Vue, you have to decide when you unwrap the ref, because if you don't ever access .value and you pass something to a Vue component, and then it gets passed down to further components that are actually accessing the value, you don't want all those components in the middle to have to update. Going back to my diagram, if we have the count all the way up in app, and the count's not being used until you're down into the span, not only should we not be updating top nav, we shouldn't even be updating counter, because counter is just passing this value down. So if you don't touch .value in counter, this shouldn't have to update. And in Solid, if you don't call count with the brackets or the parentheses, then counter shouldn't have to update either. Whether these API styles suit you is to some extent subjective. Our goal here is to demonstrate the underlying simplicity and trade-offs between these different API designs. We also want to show you that Vue is flexible. You are not really locked into the existing APIs. Should it be necessary, you can create your own reactivity primitive APIs that suit more specific needs. Yeah, overall agree. I think it's cool that they're not sitting here and saying our API is the best. Rather, they're showing you how to replicate these other APIs you might be interested in, because you can't do this in React. There is no world in which you can create signals like this in React and have it behave properly without causing weird edge cases and side effects. This is straight from Evan Yu's blog post, Vapor Mode. Vapor Mode is an alternative compilation strategy that we have been experimenting with, inspired by Solid. Given the same Vue SFCs, so single file components, Vapor Mode compiles it into JavaScript output that is more performant, uses less memory, and requires less runtime support code compared to the current virtual DOM-based output. It's still in early phase, but here are some high-level points. This is the big thing I want to emphasize here, is that it's not using a virtual DOM. So in all the examples I gave here, we kind of have this virtual representation of the page, but like app isn't real, top nav isn't real, it's probably just a div, counter's not real, button's a button, and span's a span. But this doesn't represent the actual thing in your HTML. This represents how the JavaScript code understands it. And as I mentioned before, in the React version, when you change count, it checks if app has a different output than it had before in the JavaScript world. And the only time the browser's touched is if it does have a different output, then that element gets updated, et cetera, for all of these elements. But the thing the JavaScript keeps track of is this whole tree of what is where, and that's how it's managing the state too. The state lives in this React virtual DOM tree. Vue used to work similar to this. Solid works very differently, where I have these elements, but it's almost misleading because the thing that's actually flowing through here isn't the element bindings. The way Ryan's phrased it before is you should kind of treat Solid components less like components and more like templates, where they're generating the initial HTML, but they're not running again. You're not rerunning app every time this code changes. You're changing the thing that bound count. So if you had here's a common thing that catches people with Solid. If right below the set count, I had a console.log count. Even if I call it here, this isn't going to do what you would expect. Because in React, you just put that there, and then the code reruns when you call set count. In order for that to work, it has to rerun all of the components. When your state's no longer based on the components, which is where this signal code would be defined, and it's instead based on the values, you'd have to tell the system, hey, create effect, and in here, do the console.log where you call count. And then this would create an external binding outside of the component hierarchy that is, hey, when this value changes, one of the things in its tree is this effect. You can kind of think of this like its own tree, which I'll draw out here quick, where we have count signal. So here's this count signal. And one of the places it goes is that effect I just made. This effect will run whenever the signal for count changes now. And we also have this span, which I'll just copy paste, where this goes instead. Now multiply this by every different type of state you have in your app. So if we also have, username or sign-in state and all of those things, you would create separate trees like this for all of those. To be clear, you're not doing this. You're not thinking in this way necessarily, but the way that things update isn't your component runs, then its children run, then its children run. It's the state changes, so it goes to all of the places consuming that state and updates those, which means you no longer need a virtual DOM. You just need to know all of the places count has been invoked, which is what happens when you call it the way I showed here. Right now, Vue works this way with virtual DOM elements. Even though they're using signals under the hood to determine which components should or shouldn't update, the component is still the thing doing the updating because the virtual DOM is the thing resolving that change. So let's talk about how Vapor Mode changes this, because it is no longer using the virtual DOM-based output. It's much more inspired by Solid's solution. Vapor Mode is intended for use cases where performance is the primary concern. It is opt-in and does not affect existing code bases. At the very least, you'll be able to embed a Vapor component subtree into any existing Vue 3 app. Ideally, we hope to achieve granular opt-in at the component level, which means freely mixing Vapor and non-Vapor components in the same app. Building an app with only Vapor components allows you to drop the virtual DOM runtime from the bundle, significantly reducing the baseline runtime size. And in order to achieve the best performance, Vapor Mode will only support a subset of Vue features. In particular, Vapor Mode components will only support the composition API and script setup. However, this supported subset will work exactly the same between Vapor and non-Vapor components. Enough talk, let's play a little bit. Here's a demo with the isVapor call of some Vue code in the Vue SFC playground where we are using Vapor. It's a custom Vue version so that we can actually play with the Vapor stuff. We have the Vapor on, off button here too, so we can see the effects as a result. So here we have the message, which is the ref hello world. And if we want to change it, it's already bound in the input vModel tag here. So if I change this, it automatically changes. This might seem pretty nice and simple to most people, but I'm sure React devs have a lot of feelings because this is not anywhere near this simple in the React world. Certainly not to make this performant. We're all trained as React devs to be very careful about when we bind things to an input. Scary stuff. But we can see here, it's pretty performant. I want to actually look at this JavaScript code because this is interesting and surprisingly readable. So here we have these template values that have been created. This is a huge difference because before these would have had to be virtual elements, but instead they're a template, which means it can rerun when things change and not have to otherwise. We have one for the H1, the input, and the B, which if we go back here, those are the three elements inside of this template. Now we have the render logic. I'm just going to rename these input binding. I'll call N0 the H1 binding, and we'll call N2 the Vapor Mode binding. So that we've named these a little more readably. It's a little easier to see what this code's doing. The underscore on here, this is binding the input to the update model value event. So now whenever this event occurs, which is in this case a text update event, we now have the contents of it and we assign those to the message. And when this gets set equal here, that triggers the update for everything else. Pretty cool that all of the code for this is 52 lines of compiled output and is just using these two relatively minimal imports from Vue, the ref and the get current instance. Oh, no, we have a bunch more from Vue Vapor here. Never mind. It wasn't quite that little bit of importing, but still relatively minimal. Here we have the vModel text with directives on render effect, set text, and template. Still pretty cool stuff. If we were to make some changes here, let's say we have two different inputs that can set this value. Just curious what happens. vModel equals message. Changes in all of them. In the code output, interesting, it's still only generating one template for that. If I was to add class equals bold, that forces it to do a new template. Very interesting. If the elements are identical, it doesn't create a new template for it. But if they're not, if there's any difference between them, it creates a new template. There's a lot of compiler magic going on here. Not saying that's necessarily a bad thing, but Vue, Nuxt, and this ecosystem have historically relied on a lot more compiler stuff that fundamentally changes the JavaScript outputs. This is fun and all, but what we really should be comparing to is non-Vapor mode. So I turn this off. It's actually a little less code, but this code is a lot more fragile and relies on a lot more external stuff. So in this not vapored version, we still have the SFC bindings at the top. We're importing all of these things from Vue instead of from Vue Vapor. And render is now a function that has to run with all of the context, cache, props, setup, and all of these things. It's kind of like that core render function in React. This is necessary because we have to render and re-render in order to identify, make changes, catch things, etc. And here we have this big nested flow where we're creating these virtual elements in order to set up the display bindings in order to update these things going forward. And you have to rerun a lot of these pieces when changes happen. This is a lot more like how React works. It has its benefits too, where they have optimizations here to keep certain things from updating when they don't need to, but the element block itself has to be updated when changes to the state occur. And this is inherently more complex. Not inherently more complex to understand necessarily, but inherently more complex to compute and actually run this code. Exciting stuff. They even showcase how much better the SSR render is here, because again, when you're making templates like this, you don't have to worry about this complex relationship between the virtual DOM, the update changes, and the real DOM. You're just creating the chain of what updates happen where. And here, you can see with the SSR render, we're just generating the HTML output, and now it works. Pretty nice. Where with the old mode, the SSR render had a bunch of crazy hacks with like HTML ingested in here, because the render code that works on the client is fundamentally different from the render code that works on the server, because the client side has an update model, the server side doesn't. When you're using Vapor or Solid or these other things, updates don't matter until they happen. The templating code stays the same. So this SSR render code is exactly the same as the render code in Vapor mode. That's a huge, huge difference. Versus Vapor off, you see these things are entirely different. This is cool stuff. And I'm pumped this playground's in a state where you can not just use it, but see how Vapor handles these things. It's a huge difference. And I am more excited than I've been in a while. I know I'm not the Vue guy, but I am really hyped on these types of efforts. Taking something people are familiar with and making it this much better is no easy feat. And I have massive respect for Evan and the rest of the Vue team for making this not just possible, but compelling, exciting, and a very likely future for the framework. More frameworks should be taking these opportunities. I know React has, and Solid's already here, but a future where we're compiling our frameworks to make more optimal code, that's an exciting future for me. Let me know what you guys think in the comments. Good seeing you all as always. And until next time, peace nerds.